we saw in what I was talking about earlier, that when your graph moves from increasing to decreasing, you have the potential, or you have a maximum. So if you look here, we're looking at a maximum right here. The coordinates are -2, 16. So there is one of our maximums. Here we have another maximum from increasing to decreasing is the point 2, 16. Here we have decreasing to increasing at the point 0, 0, the origin. And then notice there's two other points here because this graph doesn't continue infinitely. It has a definitive ending point here and here. So if we find these points here, you can identify if it were the absolute mins or absolute max. Okay, so here, when we look at this, since there's no other points around it, we don't think of it as localized. But when we do find the absolute, when we look right here, this absolute minimum is at the point 3 and then approximately -10. Right. If you have a question like this, there's a little bit of tolerance for being off if it's something where it might not be exactly scaled where you can read it. Okay, so this right here wouldn't be a relative minimum, but it is the absolute minimum for the whole graph. So when you look at these answers, so absolute maximums, these two different points yield the same maximum output of 16. There's no other point on the whole graph that's higher than that, so -2, 16 and 2, 16, those are both absolute maximums. The absolute minimum is going to be this ending point right down here, 3, -10 approximately. Your local maximum, okay, so even the absolute maximum can also be localized. Okay, those are also local or relative maximums. Okay, and then your relative minimum is this origin down here, 0, 0. And so that's how you would enter your solutions there.